Physics, the force between two charged particles. This is the equation for the force between two charged particles. It is proportional to the charge of both particles and inversely proportional to the distance squared. As you may have noticed, there is a constant k in the proportionality, which is 1 over 4 pi epsilon naught. Epsilon naught is 8.85 times 10 to the minus 12. The units are coulombs squared, newtons to the minus 1, metres to the minus 2, or F over m. Epsilon naught is called the permittivity of free space. The force is positive when the charges are both the same, so if they're both positive or both negative, this means that the overall force is repulsive. If one charge is positive and the other is negative, the overall force is negative, causing an attractive effect.
In the case of a test mass with a charge, here in this case being positive, being placed on the same plane as a negative charge and a positive charge, it will experience a resultant force, which is the addition of the two different forces. For example, this positive charge here has the same charge, therefore they'll experience a repulsive force, which will head in this direction. On the other hand, you have the charge over here, which is negative, and since this is positive, the overall force is negative. This leads to an attractive effect, which will cause the particle to move in this direction. As such, the motion of the particle will be as a direct result of the addition of the two different forces. In the case where the charged particle, once again positive, is placed on the same plane as two other positive charges, it will experience a repulsive effect from each one. So this charged particle, we'll call it charge 1, sends it this way, and that's force 1, whereas this charged particle will send it in the opposite direction, that way, and that's force 2. So the overall force is F1 minus F2. And eventually, at a certain distance, an equilibrium point will be reached, and at that point F1 is equal to F2, and therefore the charged particle will stay stationary. In the case where the test particle, which is of charge Q once again, is not on the same plane, so it's not in line with the other two particles, you can find the resultant force. This is done because force 1, this charge right here, Q1, will cause F1, and F2, well, that's because of the attractive force of the negative particle. And you can form a triangle with this, and using Pythagoras, you know that F1 squared plus F2 squared is equal to this resultant force squared. An example question might be like this. Essentially, we have a charge negative plate and a charge positive plate. And as a result, our test mass, which is once again got a mass this time of m and a charge of q, and it's held by a string which has tension at an angle theta. So because you have a positive charge on the other side to this negative charge, you get a potential difference which causes a force upon your positively charged mass. And then you have gravity acting directly downwards, mg, and you have the tension, which has two components, a vertical and a horizontal component. So we're going to have to equate this. So we say vertically, that way, t cos theta is equal to mg. Now, this is because tension actually works both up and down the string, so it's going to be t, which is the magnitude or the hypotenuse of your right angle triangle, times by cos theta, which will get you your vertical. Then horizontally, you can say that t sine theta, once again because t, and sine theta will give you your horizontal component, and it's equal to the force, the electric force that is affected upon the particle. Now, in between these two plates, due to our potential difference, we have an electrical field heading in that direction from negative to positive. And the actual force affected upon the charge is the electrical field strength times by the charge of the particle. Now, the electrical field strength in this case is the same as the potential difference, so V, the voltage between the two, divided by the distance between the two plates, D. So V over D is the electrical field. You times that by the charge of the particle, Q, and you get the overall force. Now, we have a bunch of equations here, and this only works because we have assumed, and they will tell you in the exam if they want this, that the particle is in fact equilibrium. That allows us to do all of our equating with no other forces in mind. And given that we have our vertical equations here and our horizontal equations, you can equate almost anything, and given the values that they give you, you can answer the question pretty easily.
Thank you for listening.